Hello and welcome back to this GCSE chemistry revision series brought to you by revisedchemistry.uk. In today's video, we're going to be looking at the pH scale and neutralization, the difference between dilute and weak and concentrated and strong, general reactions of acids, making soluble salts, titrations, and making insoluble salts. When universal indicator is added to solutions, it will change colour depending on what ions are present. Universal indicator can be used to estimate the pH of a substance using a colour chart. However, a pH probe would give a much more accurate reading of pH. The coloured pH scale shown on the screen can only be used with indicators like universal indicator, because these are the colours that the universal indicator solution will turn. Other indicators like methyl orange or phenolphthalein do not turn these colours, and so this coloured scale cannot be used. Acids are made up of hydrogen ions, which are released when acids are dissolved in water. The more hydrogen ions there are in solution, the lower the pH of that solution. Those of you doing the higher tier GCSE need to know that as the hydrogen ion concentration in a solution increases by a factor of 10, the pH of a solution will decrease by 1. A base is a substance that can neutralise an acid. The most common bases that you will come across are metal oxides, metal hydroxides, and metal carbonates. Most bases are insoluble in water, and those that are soluble are called alkalis. Alkalis are made up of hydroxide ions. When an acid and an alkali react, we can write an ionic equation to show how they make water. H plus OH minus makes H2O. When a base and an acid react, they produce a substance that is neutral. We call this a neutralization reaction. The salt and water are always made during a neutralization reaction. In chemistry, we don't often use universal indicator when we do chemical reactions, as universal indicator isn't very accurate as there are too many colours on its colour scale. We prefer to use indicators like litmus paper, methyl orange, or phenolphthalein. When we add these indicators to a solution of an acid, a neutral solution, or an alkaline solution, we get different colours, as can be shown in the table on the screen now. When we dissolve a solute in a solvent, we form a solution. The more concentrated the solution, the more particles it contains in a given volume. When we describe a solution as dilute, we mean that it contains a small amount of a dissolved solute, and a concentrated solution contains a large amount of dissolved solute. We mustn't get confused between dilute and weak, or concentrated and strong, because a weak solution means that the substance only partially dissociates into ions when it's in solution. An example for this would be ethanoic acid. A solution that is strong means that it will completely dissociate into ions when dissolved in solution. An example for this would be hydrochloric acid, or maybe even sulfuric acid. We can have a dilute weak solution or a concentrated weak solution. We can also have a dilute strong solution or even a concentrated strong solution. When acids react with different chemicals, they can make different products. Using different acids will create salts that have different names. You need to be able to recognise that when hydrochloric acid is used in a reaction, the salt that's made will have the name chloride. When sulfuric acid is used, the salt will have the name metal sulfate, and when nitric acid is used, the salt will have the name nitrate. When an acid reacts with a metal, it will make salt and hydrogen. An example reaction for this is hydrochloric acid plus magnesium makes magnesium chloride and hydrogen. When an acid reacts with a metal oxide, it will make salt and water. An example reaction for this is nitric acid plus lithium oxide makes lithium nitrate plus water. When an acid reacts with a metal hydroxide, it will also make a salt and water. An example reaction for this is sulfuric acid plus sodium hydroxide makes sodium sulfate plus water. When an acid reacts with a metal carbonate, it will also make salt plus water, but this time it also makes carbon dioxide. An example reaction may be sulfuric acid plus calcium carbonate makes calcium sulfate plus water plus carbon dioxide. There are two ways that we can make a soluble salt. The first way is from an acid and an insoluble reactant, and the second is from an acid and a soluble reactant. The first way takes an excess of a reactant, such as a metal oxide, or a metal carbonate, and it's added in excess to make sure all of the acid reacts. After the reaction is finished, we must remove the excess reactant through filtration. After we've done this, the solution remaining is only the salt and the water, so we can heat it up or evaporate it to remove the water, leaving behind the pure, dry crystals of salt. The second way uses soluble reactants, and so we must use a titration. This is because there are no insoluble excess reactants that we can remove using filtration. The acid and the soluble reactant, which is normally a dilute alkali, are mixed in correct proportions. This is because we want to exactly neutralise the acid. Adding any less or more alkali than needed will not result in a neutral solution of salt. The solution at the end of the reaction is only salt and water, and we know this because they've been added in the correct proportions to fully react with the acid. This means we can just evaporate the water to leave behind a pure, dry crystal of salt. Another reason we would be doing a titration is to try and work out an unknown value. This is normally an unknown concentration. We will look at titrations in a little bit more detail for your core or required practicals. However, for now we're going to focus on what we need to do a titration. There are several pieces of equipment that are important during a titration. The first is a glass pipette, and that is used to accurately measure the volume of a reactant before we transfer it to a conical flask. This normally has a volume of 25 milliliters. We use a burette to add small exact volumes of the other reactant, and this normally has a volume of about 50 centimeters cubed. The final piece of equipment that we need through a titration is a suitable indicator, and this is usually either methyl orange or phenolphthalein, as these give exact colour changes rather than universal indicator that has far too many colours and is difficult to tell when it's neutral. Making an insoluble salt requires you to have two soluble salts to start with. We make a solution of each of our soluble salts and add them together. We'll see a precipitation reaction fairly quickly, and we must then do a filtration to separate our precipitate as the residue. We then wash the precipitate with distilled water whilst it's still on the filter paper, and then we leave the precipitate in a warm oven or on the side to dry. How do you know what salts are soluble and which ones aren't? Well, there is a list of solubility rules that you need to remember. On the screen now you can see a table that shows those rules. You need to memorise this table to be able to identify in an exam whether a salt is going to be soluble or not. Thanks for watching today's video. Please like and subscribe if you want to see more, and until next time, thanks for watching. Bye bye.